Welcome to video 9.4a, Derive the Pythagorean Theorem. The Pythagorean Theorem is the single most important theorem in all of geometry. Just like the quadratic formula is the most important formula in all of Algebra 2. Alright, so I'm going to prove it by two different methods. It's that important. So the first method, first of all, let's state what the Pythagorean Theorem is. If triangle ABC is a right triangle, we'll say angle C is the right angle, then a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. One note about the notation, we use capital letters for the vertex points, so capital letter A, capital letter B, capital letter C, and then lowercase letters for the sides opposite those angles. So opposite vertex A is small a the side. Opposite vertex B, small b the side. Opposite vertex C is small c the side. Okay, so the first method uses the altitude to hypotenuse theorem. So given any right triangle ABC, just simply draw the altitude to the hypotenuse as shown. And all I've done is I've broken up the hypotenuse into part x and then part c minus x. Okay, so all we're going to use is these previous theorems. All right, so leg squared equals near times whole. So a is a leg, so I could write a squared equals near c minus x times whole c. And if I wanted to, I could distribute. A squared equals c squared minus cx. Okay? Let's do it again over here. Leg squared equals near times whole. So b squared equals near x times c, or I'll call it c times x. Alright, then all I'm going to do is add. So I'm going to add the left sides, I'm going to add the right sides. Let's see what we get. A squared plus b squared equals c squared. It's that simple. Method 2, a geometric way of proving it. By the way, there's hundreds of ways of proving this theorem. Method 2, geometric. For any right triangle ABC, as shown here, form this figure. Basically, take that triangle and arrange it into a large square, such that we've got 4 of those right triangles that match up with one tilted square. Okay, so all I'm going to do is try to find the area of this whole region by two methods. Find the area of the big region, just simply going this dimension times that dimension. For a square, it's just side times side. And then over here, I'm just going to add them all up individually. All right, so let's do the big square. It's this dimension here. Hopefully you guys are okay as a plus b. This dimension here is also a plus b. So it's simply going to be a plus b times a plus b. Okay, now let's find the area by just finding these 4 triangles and adding into that tilted square. So I got 4 triangles, so I'll say I've got 4 of them. And then for each triangle, the area is 1/2 base times height. So this could be the base, this could be the height. So 1/2 a times b. Okay, and then I've got to add that tilted square. That tilted square, c times c, or just c squared. Okay, hopefully you can see some things developing, especially that c squared. All right, let's just FOIL this out. We would get a squared plus 2ab plus b squared. Let's, 4 times 1/2 is 2. 2ab plus c squared. Hopefully you can see what I'm going to do next. I'm simply going to subtract the 2ab from each side. And once again, I'll get a squared plus b squared equals c squared. So it's an elegant theorem, simple to use, simple to derive. So there you have it, 2 proofs of the Pythagorean theorem.